We are going to have a quiz tomorrow. This is a practice quiz. I didn't hand it out to you. I normally don't make practice quizzes. I'll do a practice unit test, but not practice quizzes. So right now you're kind of on your own, jotting this stuff down in your notebook. Looking at the quiz, it is pretty long, so I might modify it, but this will give you a good idea of what's going to happen on the beginning part of the quiz. This quiz is technically going to be 7.1, 7.2. So if you did bad on the 7.1 quiz, you could bring up your grade by doing good on this quiz, or doing well. And the first part, numbers 1 through 6, is stating whether it's growth or decay. And in order to answer this correctly, we need to remember y equals a times b to the x power. Yeah, you might have a minus h and a plus k, but what tells you if it's a growth or decay is this b value. If the b value is a fraction or a number or a decimal greater than 1, then it's going to grow. If it's a value less than 1, it's going to decay. That makes total sense, because if you take any number you want and multiply it by something that's bigger than 1, the answer is going to be bigger. It's going to grow. If you multiply any number you want by a value that's a fraction or a decimal less than 1, it's going to decay. It's going to get smaller. So looking at this, is this a growth or a decay function? Growth. There you go. Number 2, growth or decay? That's a growth, even though some people are saying decay. In order to understand this, you need to think y equals a. Now, when I say y equals a times the base b to the power of x, notice that this negative sign does not have parentheses, doesn't have parentheses around it, so the base is not really negative 3. The base is really 3, and the a value is that negative sign. So the a value out here is really negative 1, and then you have the base 3 to the x power. So that's definitely a growth function. Number 3, growth or decay? Decay. Why is that?
Because then it's going to be like 1 over 3.14.
Yeah, whenever you have a negative exponent, you have to flip that base. You have to do the reciprocal of that base. So that's really going to be a 1 over pi to the power of x. And this is definitely less than 1. 1 divided by 3 point something is going to be less than 1, right? So it's definitely a decay. Hope you guys are seeing that, understanding that. Number 4, it's another negative exponent, which means I need to flip that fraction, flip that base. So I really have 9 times 4/3 to the x power. And now that you can see that base of 4/3 that's bigger than 1, that's 1 1/3, that is a growth function. Are you with me?
Yeah.
How about this guy? Is this a growth or a decay function? Growth. I've been saying this: put one finger on your asymptote and put your other finger on the graph itself. So you're going to have both fingers together, and look at this graph from left to right. One stays on the asymptote, one goes onto the graph. What's happening? They are growing apart from each other, right? So that's a growth function. From left to right, it grows away from the asymptote. Over here, your asymptote's right here. So from left to right, you got all this space, and it's decaying towards the asymptote, right? So that's how you know if it's growth or decay. From left to right, it grows away from that asymptote. So this is definitely a growth function. And this one, from left to right, it decays towards that asymptote of y equals 1. So this one's a decay. So you're going to have 6 of those questions on tomorrow's quiz, and that's why it could replace your previous one, because it has the growth and decay. It also has a couple extra questions right here. State the asymptote of number 7. Now, I hope we remember that your k value is your asymptote. But the correct way to respond to this would be to say y equals negative 1. That's your answer, because that's the only way that it'll produce a horizontal line at the y value of negative 1. Now, number 8 is an interesting one, because you got to actually visualize it. Y is greater than or equal to, actually not or equal to, because that would, yeah, just greater than. Right. Now let's explain it to everybody. If I were to do a sketch, what would the asymptote be? Negative 3. So if you go to negative 3, 1, 2, 3, and you draw your asymptote right through that y equals negative 3 value, And then you realize that this is a what kind of function? Growth or decay? Growth. So from left to right, it's going to grow. So from left to right, it's going to grow. So you could just sketch it like that. From left to right, it's on the asymptote, and then all of a sudden it grows. So now that the y values, the range are your y values. So they want us to state the range. All the y values of this blue function are above that asymptote value of -3. So that's the first part of the quiz. We're also going to have to graph two of these exponential growth or decay functions. I don't know, which one would you like to see? Numbers 9, 10, or 11, 12? 11, 12? All right, so let's graph this one for the sake of time. I tried doing both last class. It was way too long. So what are the steps to graphing an exponential growth or decay function? First, identify your h and k, and then you ignore h and k. What's your h value? -4. What's your k value? 0. So you already know that your asymptote to your final graph will be y equals 0, right? It will be right here at your final graph. Might as well draw it. You don't have to draw it yet, but at the end of it all, it will be right there. If it would have been a -3 as your k value, then it would be down here, your asymptote, right? Anyway, identify h and k, ignore h and k by boxing in your function and leaving out the h and k. And then you do a quick xy table, and we're going to use consecutive integer inputs so it'll be easier for us. So consecutive integer inputs, -3, -2, -1, 0, 1, 2, 3. And let's plug in the easiest one, 0. Why is it the easiest? Because anything to the 0 power, again, ignoring h and k, anything to the 0 power, 1/2 to the 0 power, that's 1. And 1 times -4 is -4. There you go. That's super easy to do. Plug in 0, becomes 1, multiply it by your a value, and you get your a value right there. What else? You could plug in 1 if you wanted to and do all that nasty math, or you could just use the growth or the decay factor to get your remaining outputs because you have them in consecutive integer order. So -4, I needed to decay by half to get to the next one. So that will be -2. And then the next one, -1. And then the next one, -1/2. And then the next one, -1/4. And the next one, -1/8. And the next one, -1/16. And we know it keeps getting smaller and smaller and smaller. So it's decaying by the factor of 1/2. Going backwards, it would be multiplying by the reciprocal of that growth or decay factor. So backwards, it'd be multiplying by 2/1, which is 2. So when you go -1 times 2, it's -2, times 2 is -4, times 2 is -8. And you know what? We're already off the graph. I mean, you could do it, but you're already off the graph. Those coordinates are unnecessary. So let's graph this first one, 0, -4. That's down here. Let me do this in red. I'm sorry. Let's go with red. 0, -4 is right there. 1, -2 is right there. 2, -1 is right there. 3, -1/2. 3 on the x. 1, 2, 3. -halfway down is right there. Now, we already know that the next one's going to be even closer to the x-axis, even closer to the x-axis, closer, closer. And you're going to draw it like if it's actually on it, right? But this is not our final graph. Our final graph is including the h and the k shift. So I need to take all these coordinates and move them where? 4 to the left, because the h value is -4. 4 to the left. So when you move every single one of these, 1, 2, 3, 4, 1, 2, 3, 4, and so on, and so on, and so on. So it's the same asymptote because it never moved up or down. The k value is 0, so the asymptote's at 0. And there's our graph. Any questions? All right. So I will be asking additional questions, kind of like these questions down here. It says, state the domain and the range of 11, 12 above. All right. So what is the domain? X equals all real numbers. That's true for any growth or decay function. It goes to the left forever. Even though it goes down, it still goes to the left forever, just it's way down there, even further, way down there. And it goes to the right forever. So yes, the domain x equals all real numbers. How about the range? Y is less than 0. Because this whole blue graph is below the y value of 0. So y is less than 0. It looks like it's touching, but it never actually touches, just infinitely approaches. What else? Number 16. On 7, 8, or that's a typo. on 11, 12 above, as x approaches positive infinity, what does that mean? Look at it to the left or to the right? To the right. X going to positive infinity. Here's your x-axis. 1, 2, 3, 4, 5, 6. Going this way is positive infinity. So we need to look at this graph to the right, going to positive infinity. What's happening to your f of x values? In other words, what's happening to your y values? Right here, you're at negative 4, and then you're at negative 2, and then you're at negative 1, then negative half, and then negative 1/4, and then negative 1/8. What's happening? Approaches 0. So f of x approaches 0. So those are the type of questions you're going to have. You're going to have 2 of those, right? And then we get to the fun stuff, the 7.2 stuff. 7.2, the rest of the quiz is similar to the questions from worksheet 7.2, but let me just go over a couple of these. Like number 17 right here, I have the base 4 and the base 16. I need both of those bases to be the same base so I could eliminate them and then the powers come down. So I could, if I wanted to, change this to a 2 squared and change this to a 2 times 2, 4 times 2, 8 times 2, 16, a 2 to the 4th. I could get the same base 2, but that would actually make numbers a little bit bigger because the 4 and the 16, I could actually change the 16 to become what? 4 to the 2nd. So since this is already 4, you might as well just change this to 4 to the 2nd. You'll be good to go. Sometimes you'll actually have to modify both. But in this case, let's just take that 16 and rewrite it as 4 to the 2nd, and it's still to the 3x minus 33. And let's distribute power to a power. 2 times 3x, that's 6x. 2 times negative 33 is negative 66. And of course, that's still the power of base 4. And there's still an equal sign here. And on this side, we still have the 4 to the power of 4x minus 6. Everybody with me so far? Okay, now that we have that same base 4 on both sides, you could cancel those 4's out. Your equation becomes 4x minus 6 equals 6x minus 66. So let's add 6. Add 6. It will become 4x equals 6x minus 60. And then let's get the 6x to the left side by subtracting 6x. Subtracting 6x. We will have negative 2x equaling negative 60. All we need to do is divide both sides by negative 2, giving us our final answer, x equals 30. Cool? All right. That was a case where I didn't have to modify both. I could just change the 16 to become that base 4 to the 2nd power. And of course, you could use calculators, guys, so it shouldn't be that difficult with calculators. Now, right here, could I change 8 to become 4 to the 2nd power? No, because 4 to the 2nd power is not 8. So right here, I have to change both of them, right? What am I going to change them both to? 2. That's right. The 4 is going to become 2 squared, and the 8 is going to become what? 2 to the 3rd. Okay, so we still have x minus 7. We still have x minus 12. Let's distribute 2 times x. We'll get 2x. 2 times negative 7, negative 14. It's still the power of base 2. Same thing over here. 3 times x, it's 3x. 3 times negative 12, it's negative 36. And it's still the power of base 2. And there's still this equal sign that's between them. So I have 2 to this power equals 2 to this power. That must mean that these powers must be equal to each other. And that's why we could actually eliminate the 2 and the 2 and get a nice problem that we could solve. 2x minus 14 equals 3x minus 36. So let's get that 2x over to the other side. We're going to end up with, running out of space here, we're going to end up with negative 14 equals x minus 36. Add 36 to both sides. We end up with x equals 22. And that's it. That's your answer for that problem. So this was an example where we had to modify both bases, right? So we're going to have a couple of these. I don't really know how many. I still need to calculate the time and how many we should put on there. I might shorten the quiz right now, but the rest of these questions are going to be similar to the ones from the worksheet from yesterday, 7.2. So we have yesterday's worksheet right here, and on the video that I uploaded I already explained 2, 3, and 15. Let's go for a couple others. Like, let's say, I don't know, which one would you guys like to see? Let's do one with an inequality. 16, 17, 18. Pick one. 17? Yeah, this is from yesterday. So let's look at number 17 here. Now, I see a 36 right here. It would be nice if 36 squared was 216, so I could rewrite this as 36, right? But with the calculator, if you try 36 times 36, will it give you 216? No. So it doesn't work. So maybe we need to change both bases. So 36 could be rewritten as what? 36 could be rewritten as what? 6 squared, right? Okay, so if I could change this to 6 squared, it would be nice if I could change this to 6 to a certain power. So let's try with the calculator 6 to the third. If I go 6 to the third, will that give me 216? Somebody check that out on a calculator, please. So if you do check 216 with the calculator, 6 to the third really does give you 216. So what I want to do is rewrite the 36 as 6 squared, and I want to rewrite this 216 as 6 to the third, right? So the 6 squared that's on the bottom, I'm going to move it up to the top by using that negative exponent rule. So when I move it up, and I'm sorry, you know what? I'm being lazy here. Let me erase this and show my work, all right? Let me erase this and show my work. Check this out. The fraction 1 over 36, I'm going to rewrite it as 1 over 6 squared. And then I want to take that 6 squared and move it up, and it will become 6 to the negative 2 power. Now, it still has the exponent x plus 8. There's still an inequality right here instead of an equal sign. And over here, we said that 216, that could be rewritten as 6 to the third, and it still has the exponent x minus 3. So what we really have now is the same base 6 on both sides. So let's distribute up here and distribute up here and get our new equation without those bases of 6. So let me distribute negative 2 times x, that's negative 2x. Negative 2 times positive 8 is negative 16. And that is, of course, the power of base 6, and you still have the less than or equal to. And then over here, when you distribute 3 times x, that's 3x. 3 times negative 3 is negative 9, and you still have the base 6. So now that you have base 6 all by itself on both sides, and you have those nice exponents, you could eliminate those base 6's. They will disappear, and your new inequality becomes the exponents. Negative 2x minus 16 is less than or equal to 3x minus 9. So now let's get x's by itself on one side. Let's move this 3x by subtracting it. Your new inequality will read negative 5x. Sorry about this mess. Negative 5x minus 16 is less than or equal to negative 9. And then if you add 16 and add 16, you'll end up with negative 5x is less than or equal to 7. And if you divide both sides by negative 5, since this is an inequality, we have to flip that inequality symbol. It'll become greater than or equal to, and you would just leave it like a fraction, 7/5, negative 7/5. So x is greater than or equal to negative 7/5. Could we verify that answer on the back of the worksheet? Okay, so you're definitely going to have one of those that's an inequality instead of an equation. The only difference is that when you divide by a negative, flip that inequality symbol the way we did right here. And also we're going to have some with fractions, or you're going to have to move up and the exponent becomes negative, all that fun stuff, all right? What else? The last questions, maybe 2, maybe 3, are going to come from this middle portion where I give you 2 points and you find the actual exponential growth or decay function. So let's do this one right here. The function that we want is y equals a times b to the x, and I do not want an h or a k. They want us to write an equation. I'm going to write an equation without an h or k, because I know that when I don't have an h or k and I input the x value of 0 right there, anything to the 0 power becomes 1, and 1 times a will be the a value. So when I don't have an h or k, when I plug in a 0, my output will be my a value, which in this case is 8. So they're indirectly telling you that your a value is 8. So we know that a value is 8. They also give you an x value and a y value. The x value is 4. The y value is 2048. And you're going to plug it all into this guy right here. So instead of y, what number am I going to write? 2048. I have the equal sign. Instead of a, what number am I going to write? 8. And it is times your b value to the x power. And instead of the x power, what am I going to write? 4 right there. So to the power of 4. So I need to isolate that b value. I want to get rid of the 8 first because it's really saying 8 times b to the 4th. So let's get rid of the multiplication of 8 by dividing by 8. What I do to one side, I do to the other. Calculator time, please help me. 2048 divided by 8. What is that? 256. Thank goodness. It's a nice number. Equals b to the 4th. How do I get rid of a 4th power? With the 4th root. And what I do to one side, I do to the other. Now, hopefully on a calculator, 256, the 4th root of that is a nice number. Is it 4? Okay. So the answer is 4. That is B. Now, that's not the actual answer. They want you to write an equation that passes through these points. And here's our equation setup. Y equals A. A is 8. The base, we just found out the base is 4 to the x power. So your answer is y equals 8 times 4 to the x power. That's our answer for number 8. So there will be a couple of those. Those are the last questions on the quiz. And you're pretty much all set to do well on the quiz. Let's just make sure that we finish this worksheet. I think I might pick some directly from the worksheet, or I might create some of my own that work out a little nicer. But either way, it's a good practice. The answers are on the back of this worksheet.